Hello, my name is Joan Sendra. I am an osteopath and yoga teacher. First of all, let me tell you that in the description, you'll find links to both in-person and online yoga anatomy courses. Now, this weekend, we're starting a yoga anatomy course in Barcelona, an in-person training. That said, today we're going to talk about support postures and the muscles that hold us up. Let's go to the screen. When we stand on both legs, that's called a bipedal stance, and it's determined by how we manage our muscle chains, which work in opposition to the force of gravity. We have the force of gravity pushing down with our weight, and we generate impulses, a learned muscular response that opposes gravity and our own weight. That's why learning is important. As we walk, neural maps are formed that memorize how we manage our muscle chains through the nervous system. Simple. The nerve impulses from the brain in the neural maps we build through learning, while walking and when we form postures, are coordinated by the cerebellum, which is responsible for muscle management. These impulses travel through the brainstem to the involved muscle chains. They are sent in bursts. This is called action potentials. At the moment when the force of gravity is perceived through the sensors distributed throughout the body. And the sense of balance we have, which we have developed through learning to walk, is activated to maintain an upright posture. As we've already mentioned, it comes from the brain, passing through the cerebellum, the brainstem, and here we have the entire network of nerves that sends those impulses to activate the muscle chains that keep us standing. Therefore, these impulses are responsible for muscle toning and relaxation to keep us upright. If we observe ourselves internally, we can notice that we are in a state of constant compensation, making slight continuous adjustments. That's why Tadasana is one of the best postures to observe these micro-movements. When we are in Tadasana, for example, we are not static. We always have small movements, swaying from one side to the other, forward and backward. And those impulses are constantly correcting our standing position, thanks to our sense of balance and the awareness of the space around us. The nerve impulses that react to gravity are automatic and we are not aware of them. All the neural maps, coordinated by the cerebellum, the nerve impulses that are initiated in the neural maps we have built throughout our lives, managed by the cerebellum, are the ones responsible for correcting our posture. But if we are sensitive and subtle, we can voluntarily correct our alignment until we find balance in our posture. The coordination of muscle chains is vitally important for proper alignment in the static postures of yoga. Japa, which means repetition, is the tool we have for memorizing muscle management. And in this way, little by automating these processes, we free the mind for deeper internal observation. For this reason, a daily routine is the best way to learn and progress in the practice of yoga. In this posture, when we properly engage muscles such as the quadriceps, pelvic floor, transverse abdominis, diaphragm, and neck, and when these processes become automatic, we allow the mind to be freer. The complex skeletal muscle chains, such as the essential diaphragm and the deep psoas, represent these main critical muscle groups in the body. The glutes, which are at the back, the paravertebral muscles, the adductors. These muscles, for the most part, are attached to the skeletal structure, and structural imbalances cause adaptations in the muscle chains, such as hyperlordosis and scoliosis, for example. If we have an excessive forward lumbar curve, we will have muscle engagements that try to correct it. And one of the main muscles is the psoas. For this reason, pathological structure leads to an adaptation in muscle management and its corresponding memorization. In the long term, skeletal deviations become fixed and increasingly difficult to correct since muscle patterns have been established that we consider normal. The practice of yoga not only has to manage the musculature, but we also need to seek skeletal correction through corrective postures. For example, if a person has hyperlordosis, which is a forward curvature, we will need to do, for instance, forward bending postures. When we bend forward, we push the lumbar vertebrae back to achieve proper alignment. But it's not just about the correct structural position, it's also about stretching the posterior muscles, in this case the hamstrings, and stretching the psoas, which passes through the groin. Therefore, we see that in yoga, to make structural corrections for the impulses of the supporting musculature, we need to make structural corrections and stretch the corresponding muscle chains. In this way, through nerve impulses, we memorize correct positions or neural maps that will manage posture more effectively. The weight and gravity loads that come from the head and thorax reach the pelvis, and there, theoretically, they are divided 50% into each limb. If there is no bone deviation, the nerve impulses will coordinate the correct support for force distribution. But if that is not the case, for example, in scoliosis or hyperlordosis, the impulses will have to send specific information to each muscle chain in each leg to maintain balance, generating compensations in other parts of the body. Within the lines of gravitational load, we find several structural and muscular diaphragms that allow for the distribution of loads and the alignments in postures. The pelvic diaphragm, made up of the iliac bones, the sacrum, and the coccyx, and connected above to the lumbar vertebrae and below to the femur bones. Muscularly, it is made up of the pelvic floor, the levator ani, the obturators. We also have the transverse abdominis, the rectus abdominis, the psoas, a very important muscle for standing upright, the gluteal muscles, the adductors, and the internal muscles of the legs. The psoas, the gluteal muscles, the abdominals, and the paravertebral muscles, we are always talking about muscles here. Large muscles are the ones responsible for maintaining an upright posture, and the pelvic floor, above all, counteracts the pressure from weight and gravity, which is the supporting musculature. This muscle group is the one that automatically receives impulses for supporting the internal organs and is energetically linked to the upper energy triangle. The muscular diaphragm, located at the base of the thorax, apart from its respiratory function, stabilizes the thorax and supports the digestive organs through ligaments, like a maypole towards the diaphragm. And the diaphragmatic movement during breathing facilitates the suction of fluids, both blood and lymph. This muscle receives impulses from the coordination of breathing, but in addition, it receives impulses for supporting the thorax, suspending the organs, and withstanding the pressure of gravity. That's why exhalation becomes a strenuous task, because we all need to understand that when we exhale, the diaphragm rises, pulling all the organs upward. And in addition, it has to fight against gravity. Energetically linked to the Anahata chakra, it is involved in the management of emotions and muscle groups such as the pectorals, trapezius, and rhomboids. The neck diaphragm, made up of the cervical vertebrae, the hyoid bone, and the insertion of the neck muscle groups and the palate cavity. The impulses are not as important in relation to gravity. However, they are instead linked to the processes of speech, chewing, and the passage of food to the stomach. Muscular imbalances, such as the shortening of the pectorals, are compensated by tensions in the cervical region and skeletal deviations, such as, for example, cervical hyperlordosis. And finally, we have the cranial vibration diaphragm, which receives impulses from the interactions of muscle groups during neuronal excitation. The skull compensates for the tensions throughout the entire body. The body generates couplings in the cervical region. Inflammation of the organs is another important aspect when it comes to support impulses, since they have to adapt to organic inflammatory processes. For example, the liver is one of the most important organs, and if it becomes inflamed, it affects the condition of all the other organs. These impulses, which are sent for corrections and adaptations to gravity, are more intense, in this case in the corrections of the supporting muscle chains. Yoga is a good way to work on these inflammatory processes through the compression and decompression of the organs. For example, if we want to compress the liver, we lean to the right side. For example, in Utthita Trikonasana, the right side bend, we compress the organs, in this case, the liver, and when we bend to the left, we decompress it. We also have twisting postures, which are fantastic for massaging all the organs. In the different asanas, we have different ways of addressing the supporting impulses, and one of them is the center of gravity. Postures where the center of gravity is lower, for example, Virabhadrasana 2, involve more intense impulses in the muscle chains, especially in the pelvic floor, since greater gravitational force is generated. The supporting impulses are energetically linked to the management of pranabala, which is an ascending energy. From the application of the bandhas, which is very important in toning to counteract the pressures of gravity and weight, that is, within the support of the structure, starting from the soles of the feet in Empada Bandha, and then Uddiyana Bandha, the diaphragmatic axis, and Jalandhara Bandha, the neck axis. The bandhas are a very important aspect for support postures, and by applying the bandhas and learning them, we encourage those nerve impulses that support the entire structure in an appropriate way. That's why we return to the beginning that Tadasana is one of the best postures for learning the body's support impulses. Well, I hope you liked it. See you next time.